Okay, so cyclohexane, of course, has 6 carbons in a ring. Cyclohexane is not planar. Original model, 19th century model by Thorne Bayer, showed cyclohexane as planar. With today's models, you can't even make planar. Just try and you can't. And actually, that distinguishes good model set from bad one. That's why I insist on you having model set like this, because you can't make planar cyclohexane, among other things. Poor model set, those are not good for this course, like this one, allow you to make planar cyclohexane. There are others that are not good for different reasons, like this one, molecular framework, or this one. None of them are very good. So you should not be using those. You could make some use of them if you're good with it, but really, Darling is the best, and then HGS that I just showed is second. Is actually it's better than Darling and more durable, but because of the cost, I wouldn't recommend it. So cyclohexane is not planar, and then if it's not planar, what is its conformation? Actually, one mathematician proved that. We didn't believe him for a long time because chemists don't know any math. But eventually, experimental results convinced us that there are 2 extreme conformations. One is chair. So you see, this would be chair conformation, model of a chair conformation. 1 carbon down and 1 carbon up, and this 4 in a plane. And here is with substituents. I showed substituents additionally in red. Red usually represents oxygen, but here to be able to see the model, to see skeleton and substituents, this is chair. And then to flip a chair, you take 2 opposite carbons, and then you lift 1 carbon up. You see, this is already old set, so it doesn't work very well. New would work better. This bond kinks. It's not supposed to kink. That shows that set is old. This is both conformation, alternative conformation, other conformation, both conformation. It looks like it's both. And so to flip 1 chair, oh boy, this is terrible. It should work much better. It should work just by flipping. So this is 1 chair. You can flip it into alternate chair by lifting. This one is down, you lift it up, lift down, and that's alternate chair. And then fix all the bonds. If you have a new model set, you won't have to fix anything. Fix all the bonds to be straight. Now, in case of both conformation, if you look at it from this side, you will see a lot of eclipsing interactions. That's unstable. So both actually twist into twist both. So both is really twist both. So these 2 carbons that I'm holding get out of the plane with each other, and that twists the both and twists the interactions so they're no longer eclipsing. They are partially eclipsing, but no longer eclipsing. Now, bonds in cyclohexane are axial or equatorial. So when you look at cyclohexane, those vertical bonds in chair conformation are axial because they're parallel to axis. They're shown here in bold, and those in dash are equatorial. So I can show you here, there are, of course, 12 carbon-hydrogen bonds, 6 axial and 6 equatorial. So if I label in this conformation axial bonds, it is red atoms, so all axial bonds labeled with red atoms. Of course, then by default, equatorials are those that are unlabeled. Then you can see I'm holding for 1 equatorial bond. So you can see 6 labeled, 3 up, 3 down, vertical bonds, they are axial. These along the ring equator are equatorial. Now watch what happens when we flip the ring from one chair to the other. I will have to do it slowly because this is really flimsy. Okay. See, so now as we flip, even those bonds that I'm not touching, those carbons I'm not touching, here flipped from axial to equatorial. So flip from one chair to the other results in bond flip from axial to equatorial. So all the labels are labeled are now equatorial. Practice doing that. Practice chair flip. Okay, I can't show you this guy. He has over 20 pounds and he's somewhere on my patio and wouldn't allow me to pick him up. Okay, you may want to practice drawing cyclohexane, but in this course you won't have to do drawing. And how flip one to the other. And so now substitution. What if there are substituents? So we have examined just original cyclohexane ring, but if there is a substituent like a methyl group, then what happens? Now two chairs don't have the same energy when we do chair flip. See, in this chair, substituent is equatorial, methyl group is equatorial. That's low energy conformation. But if we flip it, you know that the equatorial bond becomes axial. And now this axial methyl is close to these two hydrogens. That's steric interaction. In fact, if you look at it, this is carbon, 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 4 carbons. And this is actually gauche conformation of butane. That's the same interaction as in gauche of butane. That's steric interaction. So that's high energy conformation. So now we have two chairs of different energies. One with axial substituent, high energy, and when we flip it into the opposite chair, one with equatorial substituent of low energy. That's why you have to practice chair flip. And from that, you can draw a conclusion that substituent in equatorial conformation is going to be in more stable conformation because there will be no steric interactions. Also, by the way, I forgot to mention that six-membered ring has ideal tetrahedral angles, so there is no strain. So chair conformation of six-membered ring of cyclohexane has no strain. So strain decreases from cyclopropane highest, cyclobutane, cyclopentane to cyclohexane, which has conformation with no strain. Both and twist both conformations have some strain due to eclipsing interactions, partial strain. Now, when we go to larger rings, cycloheptane, cyclooctane, then strain begins to increase because of the other interactions, but we don't cover those rings. So cyclohexane is the most stable ring. And then what happens if we have disubstitute cyclohexanes? Well, with disubstitute cyclohexanes, we may have to return to them later in the course. We have first cis-trans isomerism. So if two methyl groups are on the same side of the ring, both up or both down, that's cis isomer. See, like this, two methyl groups on the same side of the ring. That's cis isomer. Both, actually no, this is trans, sorry. See, this bond is down, this is up, up, down. So this metal is up, this is down, that's trans isomer. And they are di-equatorial here. Now these two are actually quite close to each other, but still di-equatorial. If we flip it, because two equatorial bonds, we flip it, now we have diaxial. Obviously di-equatorial is more stable than diaxial. So that means previous conformation was more stable, this one is less stable. So two conformations of different energies. And that's shown here, and actually I need to post, yeah, I just noticed, let me see, just 1 minute. Yep, there are a couple more things I forgot to post. So I'll be posting on Canvas PDF, interactive PDF with all these things I was talking about, where you will be able to play with models, so conformational analysis PDFs, and conversion of formats. Yeah, two more. Although I think conversions are already on YouTube. And so in general, when you're carrying out conformational analysis of compounds, what you should do is look, conformational analysis of cyclohexane, you should look at number of axial and equatorial substituents. And so if you have equal number of axial and equatorial substituents, let's say each conformation has one axial and one equatorial, let's say something like this. See, this is 1,3, trans 1,3 dimethyl cyclohexane, one axial and one equatorial. If you flip it to alternate conformation, then it's one axial, one equatorial, it's just a different axial, different equatorial. Then two conformations have equal energy, equal stability. But if one conformation is diaxial, the other diequatorial, then diequatorial is more stable, diaxial less stable. So for each pair, you need to know that, which one is more stable. Or are they equal stability? And that may be on the test. So evaluating stability of substrate cyclohexanes. Decalin will not be on the test. Okay, and then let me just show you what I'm going to post. I want to show you this. I will be posting two more. Under additional materials, I will be posting PDF conformational analysis. And conversion of formulas, but they are already, as I said, on YouTube. Just okay, so where is the PDF? That's not right. Microsoft Edge was opening my file. I don't know why. Okay, so hopefully it starts sharing now. Yeah, okay. So this is chapter on conformational analysis as part of interactive PDF. It's not sharing very well. Let me just wait until it starts sharing. Sorry to keep you this long. This is important. That's why I'm keeping it this long. And I don't know what's going on. Why is it taking this long to load and start sharing? I keep on getting this circle that just keeps on running around. Hopefully it will start sharing very soon. And right after the class, I will post this on Canvas. I just want to show you basically how to use it. I don't know what's going on. Why is it? Let's see. I would really like to show you how to use this. So otherwise, I would let you go. and trying to see which process is holding this up. Stop sharing. Okay, I hope you can see it now. So conformational analysis of alkanes. So this is interactive PDF. And when you click on, let's say, a model like this, first there should be that warning message, like, do you really want to do this? You should accept it, so security risk and so on. So options. Let's trust this document always, or you can trust it one time only. And then when you click on it, this is animation, so it should start playing. So it should rotate, and you should be able to see a model from different sides. So this should help you make a model. This one is not rotating, I don't know why. Probably it's taking a long time to see. Maybe on your computer, if you have faster processor, something is working better, maybe you will be able to see that. Okay, let's just move on. These are much more useful. So these are interactive ball and stick models. So when you click on them, they will activate, and those are models that you can interact with. So once this appears, that means you can manipulate it. So if you use a rolling button, you can increase and decrease the size, and if you right click on it and move it around, you can rotate it to see it from different angles, like Newman projection, or like this. Oh, my cats are fighting. I need to finish this class. Or like this as Sawhorse projection. And you click away from it, it deactivates. And so that's important. You can have it you can see from butane, again, you have a movie, hopefully it will play, but more important is interactive model. You click on it, and now you can see this is staggered conformation of butane that you can enlarge, reduce, enlarge, and view it from different angles. Again, help you make a model. And that's also very important because for cyclohexane that I just discussed, again, more movies, here is interactive model for cyclopropane. Again, you can click on it, activate it, play with it, cyclobutane, cyclopentane, envelope and half chair, cyclohexane. So for all of these cyclohexanes, chair, twist boat, and these with substituents. So you can click on them and activate them, and then manipulate them. So enlarge, reduce all the enlarge, unfortunately, within the window, and then you can see rotate them at different angles, and that you can use this if necessary to help you make a model. And once you see this properly, you can compare that with your model. Unfortunately, here I selected this. Okay, and so you can see whether you did it right. Trans, cis. This is actually cis. Here is trans 1, 2, and then cis 1, 3, trans 1, 3. All of them should be here. Trans and cis 1, 4. Yeah, trans and cis 1, 4. And what the substituents are different. So larger substituent is equatorial. So if substituents are different, like isopropyl and methyl, larger substituent, isopropyl is equatorial, methyl is axial. And larger. Okay, so that's what I wanted to show you. So I'll be posting that right away. So that's it, and watch for announcements from me. So let's see. Is the fused 6-member drink Decalin on the exam? No, I said that. Decalin will not be on the exam. Yes, practice test is similar in format. The only difference is that there will be no file upload. Practice test is basically one of the older exams. And also, I don't know if I mentioned that, I'm taking into account that we have less time. Some of you may be disappointed that the exam is on Tuesday and not Thursday. So I'm taking that into account when adjusting level of difficulties of the question, because any exam that we write is a mix. It has some very easy questions that everybody should be able to answer, intermediate, and very difficult that maybe only A students can answer. And so, because the exam is on Tuesday, and we had less time to cover the material, and also you have less time to study, I'm both limiting amount of time, but also I'm removing some of those A questions and replacing them with intermediate questions, and removing some intermediate and replacing them with easier questions. Typically, to write an exam, I take an old exam and change all the questions with equal level of difficulty. Sometimes questions are completely different, but they're same level of difficulty. But now I will be changing them with, as I said, more of the easier questions. And so had the exam been on Thursday, then exam would have been noticeably more difficult. So just keep that in mind. That's everything. Watch for announcements from me, because if necessary, I will do then another sort of tutorial section that will not be compulsory. You will not have to attend it if you don't want to, but if it will certainly be there if we cannot secure tutoring. So it will be Monday evening. Before I let you go, actually, let me stop recording.